Right, here's something that you might not have seen before. It's the shift operators, and there's 3 of them, and they operate on integral types only. So there's no question of them operating on float or double. Right, what they do is they take the bit pattern in the left hand side and they shift it by the amount specified in the right hand side, either to the left or to the right. And if they're shifting to the right, there's 2 versions. One version propagates the sign so that into the spare place on the left hand side, when you shift it, the sign bit gets inserted. So it's effectively dividing by 2. And in the second case, it's putting 0 into the left all the time. Now there's one thing about this which is different to normal binary operators, and that's that they do unary promotion is done on both sides separately. So it means both sides will end up being integral type. And the type of the result is the promoted type of the left hand side, which is going to be either int or long. So what you might end up with is the right hand side being promoted to int and the left hand side being promoted to long. So they're not necessarily the same. So there's a difference there between that and binary promotion, which would make them both the same. Right, if the promoted type on the left hand side is an int, only the lower 5 bits are used on the right hand side, and that will give you a shift distance of 0 to 31. And if it's long, you use 6 bits on the right are used, and that will give you a shift range from 0 to 63. Here's a few examples. If we take this int literal here, shift it left by 4, of course that is equivalent to shifting the whole lot up and putting a 0 in front, because we're in hex here, and that'll be 4 bits. If you take something like this, byte equals minus 64, and you shift it right that way, that's a normal way of shifting. You'll get divided by 2 and then divided by 2 again, which means you'll end up with minus 16. And you've got to put this cast in front here because it's promoted obviously to an int, so you've got to cast it. If you do it this way, with 0 being inserted on the right hand side, you will also get 16 provided you cast it. If we take a look at this example here, we've got I as an integer, an int, and we put minus 64 in and do the same shift again this time, you'll end up with that. They're quite a large integer, which turns out to be that. Because what's happened is that if you look at these 2 bits, the upper 2 bits of this are 0. If you look at 3, it'll be 0, 0, 1, 1 in binary. If you look at something like that, 5.1 left shifted by 2, that'll be an error because it's not an integral type. Now these shift operators have got lower priority than plus or minus. So if you see something like that, for instance, what it means is that the plus and minus have got higher priority, so you can imagine a pair of brackets around those to work that out first, and then you do the shift. So it works like that, not that. That's a different answer. And they're processed left to right, and I can't for the life of me think why anyone would do this down here, but if they did, it would mean that. Okay, so pretty much nonsense here as far as I can tell. I can't imagine anyone would actually do that, but that's what it means.